Alright class, welcome to project mapping. If you've gone through the slides and read the material, now you're ready to map out a project. Some of the common language that we need to talk about for AON network, activity on node. We're going to represent an activity in this situation with a box, and we'll have a letter in there that designates that activity. In this case, the node is going to be an arrow, and an arrow will point to the activity that comes after this one. So if I'm building a house, A might be prepare the foundation. Once the foundation is done, I can put concrete down. Once the concrete's done, I can do electrical, and I can do the framing. So you see how we're mapping out the network. Activity is what needs to be done. Arrow is what can be done after that. When we have one activity that is followed by two activities, we call that a burst activity. If you were in class, I'd shout that out. I'd say burst, like that. Anytime we have a couple of activities, two or more, that eventually go into one activity, we're going to call those merge activities because we're merging back into one. We can also sometimes have activities that are all done at the same time, and those are our parallel activities, ones that can be done the same way. What we want to do is we want to figure out the critical path, the path that has absolutely no resistance, or no buffer, no fluff in it, and that's called doing our critical path method, or another terminology, CPM, critical path. To do this, we're going to do kind of a forward pass and backward pass. Each of the activities that we have, we'll say this is activity A, is going to have a certain amount of time that it takes to get done. We'll say 10 days for this one. To calculate our forward pass and backward pass, we're going to use always starting off, the first activity starts at day 0. Then you add the amount of time it takes to do that activity. That's your ending time. So this is our earliest start, our earliest finish. That earliest finish would then be the earliest start of the next preceding activity. When we work our way backwards, we're going to have down here our latest finish and our latest start. If these numbers don't match up, then that means we have slack time. Probably one of the best ways to do this is just to jump right in and do one. We have an activity here, or a project, that has been laid out for us in what we would call a project network, or a little activity breakdown. We're going to design the project. We're going to do the prototype, evaluate the equipment, test the prototype, write the equipment, write methods, report, write the final report. Certain things can be done in parallel. Others are burst activities. Others are merge activities. We can tell that by who the predecessors to each activity are. And we have the time it takes to do each activity. First thing we want to do is just simply map this out, draw it out. A is our first activity, and it does not have a predecessor. It looks like B and C both are preceded by A. That means A is a burst activity. B comes off of D. Wait a minute. I'm sorry. D comes off of B. E comes from both C and D. So that would have two arrows because that is a merge activity. That means that E cannot start until D and C are both done. So whatever one is finished later would be the start date of E. F is also from C and D. Sometimes these things can get a little tricky with the way we draw them. let's put F down here then. And let's have a D and a C pointing at it. And finally, our final activity is G, which comes from both E and F. We mapped it out. Now let's fill in our times and do our forward pass and backward pass. A takes 21 weeks or days, whichever we're looking at. B is 5. C is 7. D is 2. E is 5. 8 and 2. Let's do our forward pass. We always start at the beginning on 0 days. 0 plus 21 means A will finish at 21 weeks or 21 days. Let's just talk days. That means both B and C will start at day 21. 21 plus 5 is 26. 21 plus 7 is 28. Now I have to be careful. It looks like B and D, I can't go to E yet because C is not the only predecessor to E. First I have to know what D's time is. D will start on day 26 and will take 2 days. We'll finish on 28. Now these happen to be the same number. If they weren't, we would take the larger of the two, or the later of the two, and that's when we would start E. 28 plus 5 is 33. I cannot simply put that 33 on G. I need to find out what F is first. F is going to be the later of also 28 or 28, which is 28, plus 8 is 36. Therefore, G would start on day 33 or day 36. Has to be day 36, because if both E and F are done, we have to wait till the latter is done. 36 plus 2 is 38. Our project right now is expected to be completed in 38 days. But to determine the critical path, we need to go backwards now and find out which of these items are critical path items and which of them are not. The ones with slack time are going to be non-critical path items. We start backwards and work our way to the beginning. Take our 38 days as our finish time. That's also going to be our latest finish. On our last activity, our earliest finish and latest finish will always be the same. 38 minus 2 is 36. There's no slack time there because those numbers are the same. So already I know that G is part of my critical path. Now let's take that 36 and follow both of the nodes backwards. 36 is when latest finish for F, and 36 would be the latest finish for E. 36 minus 8 is 28. There's no slack time there. That tells me that F is going to be part of my critical path. What happened to E though? We had 36 minus 5 is 31. Those numbers do not match up. That means I have a slack time of whatever the difference is. In this case, 3 days. Already I know that E is not one of my critical path items because it has slack time. Now we take the 31 or the 28, both of them up to D. When we are working backwards, we take the lower of the two numbers. So this would be 28. 28 minus 2 is 26. No slack time. D would be part of our critical path. 26 minus 5 is 21. No slack time. B is also part of our critical path. I can't tell yet what A will be without going this direction. 28 or 31, I take the lower of the two. C will be 28 minus 7 is 21. There's no slack there. That means C is also part of my critical path, but C is parallel as B. So that means I'm going to have potentially two critical paths here. 21 and 21 are both the same, so A is part of my critical path. It looks like I only have one activity that has slack time. Therefore, I have multiple critical paths. From A to B to D, down to F, over to G, there's no slack time. So that's what I have here, A, B, D, F, G. But I also have from A to C to F to G as a critical path. That would be my second critical path. If I were to delay any activity in here due to resources, the only one that I could delay would be activity E without causing some permanent delay to the entire project. Let's put that on hold there for a minute.